Hello everyone, welcome back to Screw Gauge series, and this is the part 4. In this part, we learn the step-by-step procedure to take the measurement using the screw gauge. The first step is to determine the zero error. So first of all, when the instrument is given to you, whether it is a screw gauge or a vernier caliper, the first step is to find out whether it is having a zero error or not. To do that, you rotate the thimble with the help of a ratchet until the spindle come in contact with the anvil. So when both the anvil and spindle they are in contact with each other, you check the zero line of the head scale. So if it is exactly coinciding with the reference line of the main scale, then the given screw gauge is said to have no zero error. So if the zero of the head scale, if it lies below the reference line, then in that case the given screw gauge is said to have a positive zero error. Or if it lies above the reference line, then the screw gauge is said to have a negative zero error. In both the cases, you need to calculate what is the zero error of the given instrument, whether it is a positive zero error or the negative zero error. To calculate the zero error, we need to note down the head scale division, and also we need to know what is the least count of the given instrument. So now we go for the next step. So in the next step, to determine the pitch of the screw gauge. So to calculate the least count, so we need to know what is the pitch first. So we go for the calculation of the pitch of the screw gauge. So what is the definition of pitch of the screw gauge? So it is the distance moved by the tip of the spindle. When the head of the screw gauge, it makes one complete rotation. We rotate the thimble with the help of ratchet. Okay, maybe 3 times or 4 times or 5 times. And then we note down the distance moved by the tip of the spindle on the main scale. And then we take the average, that means total distance moved by the spindle divided by the number of rotations. Okay, that is the pitch of the screw gauge is given by the formula distance covered by the tip of the screw for n rotations divided by the number of rotations, that is n. So usually in the case of a standard screw gauge, the pitch of the screw gauge it is of 1 millimeter. The next step is to calculate the least count. Since we have the value of the pitch, then we go for the least count, that is pitch divided by the number of head scale divisions. In the case of a standard screw gauge, the number of head scale divisions are 100. Therefore, the pitch, that is 1 mm, divided by the 100, that is head scale divisions. That gives 0.01 millimeter. So this is the least count of the standard screw gauge. If we go for the next step, that is fix the object between the anvil and spindle using the ratchet. So when you place the object between the anvil and spindle, you rotate the ratchet instead the thimble. So when you use the ratchet for fixing the object, so you can avoid the extra pressure. The next step is to note down the main scale reading and then the head scale coinciding division to calculate the head scale reading. The final step is to calculate the total reading. So same like in the case of the vernier calipers. So here also we add two readings that are from main scale and then the head scale. That is, the total reading is given by the main scale reading plus the head scale reading, and head scale reading is calculated by taking the multiplication of head scale coinciding division, that is also indicated by HCD, into the least count. This gives the total reading of the dimension that you are measuring using the screw gauge. And finally, once you get the total reading, if the given screw gauge is having any kind of zero error, then we have to make the corrections. So if it is having positive zero error, then you have to do the correction, that means negative. And in the case of a negative zero error, you need to do the positive correction. And now we go for practically measuring the dimension of any object using the screw gauge. So this is the standard type of screw gauge. And you can see that 25 into 1. That means there are 25 divisions on the main scale. So each division is of 1 millimeter. That is the length of the main scale of this screw gauge. It is of 25 millimeter or 2.5 centimeter. So you can also see divided by 100. So that means there are 100 divisions on the head scale of the given screw gauge. And what is the first thing that we need to do whenever you take the instruments like the vernier calipers or the screw gauge? Okay, the first thing you have to do is you have to check for the zero error. And the parts, you can see that this part is the anvil, the small cylindrical part that you see on the left hand side, this is the anvil, and the lengthy cylindrical structure that you see, that is movable, okay, that is called spindle. And this is movable because of the thimble. For rotating the thimble, okay, there is one more attachment at the end, okay, this is called the ratchet. For fixing the object, okay, we need to use always the ratchet. Okay, now we go for the zero error. So for that, we need to rotate the thimble, okay, with the help of ratchet, okay, until, okay, both the anvil and spindle, they come in contact completely. So after that, we check the zero of the head scale, whether it is coinciding with the reference line or not. So we look closely and then we check the zero line. The zero of the head scale, it is above the reference line by only one division. That means it is having a negative zero error of one division. So after that, we need to calculate the zero error. So for that, we should know what is the least count of the given instrument. That is the next step. So what is the least count of the given instrument? So here it is a standard type of screw gauge. Therefore, the pitch of the screw, it is of 1 millimeter, and the number of head scale divisions, you can see there are 100. Therefore, the least count of the given screw gauge is 1 divided by 100, that is 0.01 millimeter. So here if we take the first object, that is the wire, a copper wire. So we find out the diameter of the copper wire or the thickness of the copper wire. So what is the next step? We need to fix the object here in between the anvil and spindle. We open the spindle and then we place the object in between the anvil and spindle, and we fix the object with the help of ratchet. So you can see here, I'm just fixing the object. Okay, and here the tick sounds, okay, it should come either 2 or 3. Okay, so 3 tick sounds. So object is fixed now. Now we go for the reading. So what is the first thing? The main scale reading. You look closely and then you note down the main scale reading here. From the main scale, okay, that is only one division is visible. It is in between the first division and the second division. Therefore, we note down the reading, that is 1 mm for the main scale reading. And then the head scale coinciding division. So we look more closely here. So it is 32. So 32 is the head scale coinciding division. Now we take the readings for the thickness of a metal washer. Okay, we place the washer in between anvil and spindle. Okay, and we fix the object with the help of ratchet. So we rotate the ratchet until 3 tick sounds are coming. And then we note down the readings. The first thing is note down the main scale reading. That is, you can see that, okay, 1 mm is the main scale reading. And the head scale coinciding division, that is 21. So now, okay, by using these readings, we calculate the thickness of the wire and then the thickness of the metal washer. Now we go for the calculation part. Okay, we have both the MSR and SCD readings for wire and washer. Okay, for wire, the MSR is 1 mm and the SCD is 32. For washer, the MSR is 1 mm and SCD is 21. And also we have noted down the least count of the screw gauge, that is 0.01 mm. The given screw gauge, it has negative zero error. So for that we have noted down the SCD value, that is head scale coinciding division when both the anvil and spindle are in contact. That is 1. We can calculate the negative zero error. Okay, that is 1 into the least count, okay, that is SCD into least count, that gives minus 0.01 mm, that is negative zero error. And the correction for the negative zero error is plus 0.01 mm. Okay, that means we need to add 0.01 to the total reading. So here for wire, okay, we have the values 1 and 32. Therefore, we calculate SCD into LC, that is 32 into 0.01. Okay, that will be 0.32. Okay, therefore, we note down the 0.32 here. That is the head scale reading. So we need to add both head scale reading and the main scale reading. Therefore, it will be 1 plus 0.32, that is 1.32 mm. And then the corrected reading, that means we need to add 0.01 to 1.32. That will be 1.33 mm. Okay, this is the thickness of the wire or the diameter of the wire. And coming to washer, okay, we have the reading that is 1 and 21 as MSR and HCD. Therefore, okay, we calculate the head scale reading, that is HCD into LC. That will be 21 into 0.01. That will be 0.21. So we note down the value of head scale reading, that is 0.21. Now we need to add head scale reading and the main scale reading. So that is 1 plus 0.21, that will be 1.21 millimeter. Now finally we need to correct it. That means we need to add 0.01 here. That will be 1.22. The final reading will be 1.22. This is the thickness of the metal washer. Okay, with this, okay, we have practically measured the thickness of the wire as well as the thickness of the metal washer by using the screw gauge, by following a proper procedure. And in the next part of this series, we will see few questions from previous IIT JEE papers. So with that, the series will be completed.